Mathematics made easy, no more fear. Target online class, we got you. Wherever you want to from, we got what you need. Target online class.
Good day, viewers all over the world. You are welcome to Toydel online class. We want to look at direct product groups. So we want to look at direct product groups. So now let's take the definition. Given two groups, H and K, and the Cartesian product H cross K, which is given as H comma K for all H that belongs to H, and for all K that belongs to K, the group. So H cross K is a group. The group formed by the direct product of two or more groups is called a direct product. It's called a direct product group. Okay, now let's look at given two groups H and K, as we have it on the board. If you are given two groups H and K as we have it on the board, and the Cartesian product H cross K, that is, small letter H is the element in H and small letter K is the element in group K, for all H in H and for all K in K, as we have it there. So H cross K is a group. That is, this is a direct product group. This H cross K is a group. Then the group formed by the direct product of two or more groups is called a direct product group. So H cross K is a direct product group. So I want to give us an example now. I want to use an example to explain this direct product group very well. So let me use example. So let's use example to explain this direct product group. Example. Let's see example. Given the groups Z4 plus and Z5 asterisk multiplication, show that Z4 cross Z5 asterisk is an abelian group. Okay, that's what we have. We have the cross product of two groups. The first group is Z4, but the binary operation there is addition. Then the second one is Z5 asterisk. That asterisk simply means zero will not be included. Zero will not be included there. So zero, that is the implication. So we want to show that Z4 cross Z5, which is direct product group, is an abelian group. Of course, for Z4 cross Z5 asterisk to be abelian group, there are 5 properties that we are going to check. The first one is we check for the closure property. We go ahead and check for the associative property, existence of identity elements, existence of inverse elements, then commutative property. Those are the 5 properties that we are going to check. Those are the 5 properties that we are going to check. So now let's go. So let's start with what is Z4. So Z4 under addition will be 0, 1, 2, 3. Okay. So anything that 4 will be 0 because it's Z is modulo 4. So anything in the multiple of 4 will be 0. And if you have 8 here, it will be 0. If you have 12, 0. Anything in the multiple of 4 will be 0. Then Z5 asterisk, that simply means that 0 is excluded from this set. We are going to have 1, 2, 3, 4. These are the elements of this other set. Okay, this is the element of this. And if you have Z4 asterisk, 0 will be excluded. We only have 1, 2, 3. I hope we understand that. So this is Z4 integer modulo 4. Under modulo 4 now, because it is addition, the binary operation here is addition. The binary operation is addition, so 0 will be included. But when the binary operation is multiplication, 0 will be excluded. You understand? Okay, that is what we have. Then what is Z4 cross Z5 asterisk? That's what you want to check now. We first list out the elements. This is what we do. We first pick 0, the element here. We pick every other element here. We come back and pick 1, pick every other element here. We pick 2, the same thing, then 3, the same thing. That is, we have 0, 1. Where 0 is from Z4, 0 is from Z4, Y1 is from Z5. Then we go ahead and pick 0, 2, 0, 3, 0, 4. We pick everything. We go to 1. We go to 1. We pick 1, in that order. So we also go to 1. We said 1, 1, 1, 2, 1, 3, 1, 4. Okay. Then we go to 2. We have 2, 1, 2, 2, 2, 3, then 2, 4. Then we go to the last one, 3. 3, 1, 3, 2, 3, 3, then 3, 4, which is the last element there. So these are the elements that we have in Z4 cross Z5 asterisk. So please look at it very well. Let's look at it very well. These are the elements that we have there. Okay. So with this element now, we now go ahead and show the 5 properties that will make Z4 cross Z5 an abelian group. That is what we are about to start now. Of course, please let's note, because I'm about to rub off the board now. Let's note all these elements before we now start to show. You know, this is the meaning of direct product. That is, you pick the first element from the first one, then the second element from the second one. First one is addition. The binary operation is addition. Second one is multiplication. We are going to see the effect now by the time we begin to show the properties. So now let's start with the first one, the closure property. So the first one I want to test for is the closure law or the closure property. Under the closure property, we have for all AB and CD, okay, that belongs to Z4 cross Z5 asterisk. Look at this. A is the element of this first one, then C is the element of this first one. B and D are the element of this second one. A is the element of this. C is the element of this. Then B is the element of Z5 cross. Then D will be an element of this. So please look at it very well so that we'll be on the same page. For all this that belongs to this, we know that A, C belongs to Z4 and B, D belongs to Z5 asterisk. Then what can we say about that? A, B into bracket A, C, D. What would this give us? Will not be equal to, under this first one, the binary operation under Z for this addition. So we are going to have A plus C, the second one is multiplication, BD. Please look at it very well. And this automatically belongs to Z4 cross Z5 asterisk. So please look at it very well. Look at it very well. The first element is the first element is for Z4. The second element, is for Z5 asterisk. So under the closure property, that's what we are going to have. Okay. Why do we have it? And this is closed. It's closed since it is closed since A plus C belongs to Z4 is addition. That's binary operation under this. And BD belongs to Z5 asterisk. That is multiplication. The binary operation of Z5 asterisk is that. So we can see example. E.g. I'm just showing example now. In the subsequent law or properties, I may decide not to show example. If we have 1, 2, 3, 4. Okay. If we have 1, 2, 3, 4, what would this give us? This will be 1 plus 3, because this first one is for Z4. Okay. It will be 1 plus 3, 2 times 4. And at the end of the day, we are going to have 1 plus 3. 1 plus 3 is 4. Because we are in Z4, 4 will be equal to 0. That is Z4 modulo 4. Anything that is 4 will be 0, or multiple of 4 will be 0. So this is going to give us 0. Then in this case, we are in Z5. This second one is Z5. 2 times 4 is 8. So 5 in 8. That is 1. Remember 3. So this will be 3. And that's what we are going to get. I hope we understand what I'm talking about. So since we are able to get this, when you check the elements, element in Z4, 0 is there. If you check the element in Z5 asterisk, 3 is there. Therefore, we now conclude that the closure law holds. We have been able to show that. That the closure law holds. So we go to the second law or property, and that is associative law. Associative. So let's take the second law or property. We are taking the 5 laws because we have to show that it's a abelian group. Okay. So associative law. So I hope we understand this first property. So let's take the second property, associative law. In this case now, there are 3 elements. We consider 3 elements. We say for all A, B, C, D, then E, F. These are the 3 that belongs to Z4 cross Z5 asterisk. Okay. For all this, can we get AB, CD, then multiply by EF? Can we write this? That is just that we pick this first 2. We now get the result to multiply by this last one. Can we write it in such a way that we are going to have AB, then into brackets CD, EF? That's what I'm about to do here now. If you're able to do that, then it shows that the associative law also holds. So if you're able to do that, it shows that associative law also holds. And that's what I'm about to do now. Okay, that's what I'm about to do now. So what can we see here? So in this case now, what can we see? A and C belongs to Z4. So I'm going to say A plus C in that first bracket, A plus C, comma, in this bracket, BD. That will be B times D, because that is E, comma F. This first one is addition, this one is multiplication. So the first two elements I had, the last two elements I multiply. And I want to relate it with this. Then how do I relate it with this? Then I will open up. Then here I have, in this four corner, I have a plus c. So here I'm going to have a plus c. I'm relating a plus c. Then I'll pick this first one, plus e, comma. In this case, I will have bd, then comma f. That's what I'm going to get. So please check. The first two elements here is addition. The last two, all the last elements are elements of Z5 asterisk, and it is product. All the first elements are elements of Z4, which is addition. So this is what we have. Then can I rewrite this? Yes. Is it possible to write this? I can bring out A now. I'll say A plus, then I put the four corner, the bracket here, to be C plus E. I'm just trying to rewrite it. In this case also, can I bring out B? Yes. Then I will have B, I will have DF. So at this point now, what is the interpretation of what I have on the board? How do I interpret this? This is the same thing as I can bring these two together to say A comma B into brackets. I brought out these two. Then I'm going to have, this is C, this is E. I'm going to have C comma D, then E comma F. And that is what we are about to show. And that's what we have shown. So I've been able to show that if I pick the first two and now relate it with the third, it's the same thing as me picking the last two, now relate it with the first. So since I'm able to show this, then I'll say therefore the associative law holds. So I've been able to show two laws or property out of 5. So I've been able to show two laws or property out of 5. So we go ahead and show the third one, existence of identity elements. So we go ahead and show the third law, existence of identity elements. Of course, for the Z4, the identity element is 0 under addition. Then for the Z5 asterisk multiplication, the identity element is 1. Okay, so under the identity element, we don't really have much to say. So let's just follow the step. Okay, under identity element, what do we have? We know that is 0, 1 is the identity element. How do we know? It's an established fact that the identity element under addition is 0, while the identity element under multiplication is 1. Okay, identity element in Z4 cross Z5 asterisk. So that's the identity element. Okay, since for all AB that belongs to Z4 cross Z5 asterisk, we can have is 0, 1 to A, B. Of course, which is same thing as is 0 plus A, 1 times B. At the end of the day, we are going to have 0 plus A is A, 1 times B is B. We are going to have AB. And what is the implication? It simply means that this 0 and 1 has no implication on this AB. It has no effect. Also, normally under identity element, we say AE, which is same thing as EA, which is same thing as A. Is that you have it at the left or at the right hand side? Also, if we reverse it and say, also if we say AB into bracket 0, 1, it will still be the same thing as A plus 0, then B, A plus 0, B times 1. So which will also give us A, B. So that's the identity element. So that simply means that there is an identity. There is an identity element in Z4 cross Z5 asterisk. So please note that there is identity elements. So we have been able to show the identity elements. So we have been able to show the identity element. We have been able to show the identity element. So we have been able to show the identity element. Okay, so we go to the fourth one. The fourth law or property, that is inverse. That is inverse elements. Existence of inverse. Existence of inverse elements. Okay, existence of inverse elements. Existence of inverse elements. So that's what we are about to show. So under the existence of inverse elements, what do we have? This is what you have. Just say for all A, B that belongs to Z4 cross Z5 asterisk, there exists an inverse. There exists an inverse. Let the inverse be A prime comma B prime that belongs to Z4 cross Z5 asterisk. So there exists an inverse that belongs to Z4 cross Z5. Okay, where A prime is inverse of A in Z4 and B prime is the inverse of B in Z5 asterisk. That's what you have. Okay, such that if you have A comma B and A comma B, A prime comma B prime is same thing as A prime comma B prime into bracket A comma B will give us 0 comma 1. That's an established fact. That is, when we have inverse, if you have inverse, so if we have inverse, so if we have inverse, that's what we are going to get. So that's what we get. If we have inverse, that's what we are going to get. Okay, so it shows that with this we can actually check with all the elements there. So since we're able to show this, then it simply means that every element in Z4 cross Z5 asterisk has an inverse in Z4 cross Z5 asterisk. So that's what we get. It shows that every element has an inverse in Z4 cross Z5. Then we show the last identity. And that last identity, is commutative law. This is the last identity. So in this case, we have for all A, B, and C, D that belongs to Z4 cross Z5 asterisk. If we can get A, B, and C, D, which is equal to A plus C, then B multiplied by D, can we rewrite it as, say, C plus A cross D, B? If you're able to show that, that simply means that we have C, D, and A, B. Since we are able to show this, then it shows that the commutative law holds. Hence, since we are able to show everything, hence Z4 cross Z5 is an abelian group. And that is what we are asked to show. So since we are able to do that, since we are able to show all the 5 properties, it shows that it shows that Z4 cross Z5 asterisk is an abelian group. And that's what we are asked to show. So I would love to stop here because of our time. We'll continue from there some other time. Thank you.